It was the year 1952 when America first caught the flying saucer fever. A rash of strange sightings was reported in the skies over Washington, D.C. Were those unexplained radar blips, unidentified aircraft, or something much more outlandish? The Washington, D.C. sightings of the summer 1952 are also known as the Big Flap. But it all started in 1947 when a search and rescue pilot reported 9 saucer-like things flying like geese in a diagonal chain-like line. Their speed reportedly exceeded 1,000 miles per hour. Within mere weeks, the sightings of flying saucers were reported in 40 other states. Later, the explanations were found. The sightings were either hoaxes or misidentifications of known aircraft and natural phenomena, but a few cases remained unexplained. By 1952, the UFO investigation unit called Project Blue Book had been founded. It was led by Captain Edward Rubbold. He and his team would have continued to investigate a few dozen sightings per month, but for the April 1952 issue of Life magazine, with an eye-catching headline, "There is a case for interplanetary saucers." The article made quite a convincing case. It spoke about 10 unexplained UFO incidents, claiming that the flying objects were extraterrestrial in origin. According to the Washington Post, after the appearance of the article, the number of UFO sightings grew more than sixfold, from 23 in March 1952 to 148 in June. By July, the UFO mania was in full swing. All that was missing was a spark. And it happened before midnight on Saturday, July 19th, 1952. An air traffic controller at Washington National Airport spotted 7 slow-moving objects on his radar screen. They were far from any civilian or military flight paths. He called his supervisor and joked about a fleet of flying saucers. Simultaneously, 2 other air traffic controllers at National spotted a bizarre bright light hovering in the distance. It suddenly dashed away at breakneck speed. At Andrews Air Force Base, located nearby, radar operators detected the same unidentified blips. Those were slow and clustered at first, but then they raced away at a speed higher than 7,000 miles per hour. One Andrews controller looked out of his tower window and spotted something he later described as an orange ball of fire with a tail. A commercial pilot flying over the Virginia and Washington, D.C. area saw 6 streaking bright lights resembling falling stars without tails. 2 jets were sent to search for the UFOs, but every time they got close to the locations shown on the radar screens, the weird blips would disappear. By dawn of July 20th, the objects were gone altogether. Ruppelt, the lead investigator of Project Blue Book, found out about the sightings just a few days later after flying to Washington, D.C. and reading news reports. He tried to get to National and Andrews to interview the radar operators and air traffic controllers, but wasn't allowed to take a government-issued car. He had to fly back to Ohio with nothing. In a few days, UFOs were back over the Capitol. The same radar blips appeared again. Radar operators were wondering whether those dozen or so objects could be caused by a temperature inversion. That's a common occurrence in DC's muggy, scorching summer months. It occurs when a layer of warm air forms in the low atmosphere. It traps cooler air beneath. In this case, radar signals can bounce off the layer at shallow angles and create an impression of near-ground objects in the sky. To be safe, 2 more aircraft were sent to chase down the unidentified targets. The jets raced to a location targeted by radar, only for the blips to disappear. Eventually, one of the plane pilots saw a bright light in the distance and gave chase. But even though he was flying at maximum speed, he didn't manage to overtake the lights. At a press conference, representatives of the Air Force offered the public some easy-to-swallow explanations, having opted for the temperature inversion theory. After that, UFO sightings dropped from 50 a day to 10.
In the middle of the previous century, flying saucers were constantly making headlines. America was going through a surge of reported UFO sightings. So it shouldn't probably come as a surprise that the American authorities, namely the U.S. Air Force, created a couple of short-lived programs. Those were Project Sign and Project Grudge, and their main goal was to look into that phenomenon. These programs were followed by likely the most famous of them all, Project Blue Book. It was a large-scale government study that lasted from 1951 to 1969. The initiator of this program was Major General Charles P. Cabell. He was a former intelligence director of the Air Force. Project Blue Book scrupulously gathered over 12,600 reports about people seeing bizarre unidentified objects in the sky. After thorough research, it was determined that most of those had natural, quite mundane explanations. As for the rest of the reports, the members of Project Blue Book simply didn't have enough data to evaluate them. That's why support for their efforts dwindled. Officially, Project Blue Book was closed in December 1969. But apparently, it didn't make American authorities lose interest in UFO sightings. Because in mid-December 2017, the world found out that they had secretly launched one more UFO research program in the late 2000s. Accordingly to certain documents, American authorities spent around $22 million over a 4-year span on a project called the Advanced Aviation Threat Identification Program, aka AATIP. This project was started in 2007, and its main goal was to study UFO phenomena. Most likely, all this activity was triggered by the 2004 Tic Tac incident. That's when a few U.S. Air Force pilots spotted unidentified flying objects off the coast of California. They captured them on video. None of the pilots could figure out what these objects were. They behaved in a weird way, as if our laws of physics didn't apply to them. They were reportedly flying extremely fast and rotating in unpredictable movements. It looks as if after that incident, American authorities decided to investigate whether those objects could be identified or not. And if not, they were eager to know where they had come from and if they had been a threat. When the New York Times story about the new project broke, officials announced that the study had been terminated in 2012. However, there were people who claimed that the program was still ongoing. One of those was a military intelligence official running the program until they quit in October 2016. In any case, let's have a closer look at this mysterious program. Indeed, the areas of research funded by the project resembled things you could find in Star Trek. For example, one grant was for the study of traversable wormholes, stargates, and negative energy. This study was conducted by Eric W. Davis of EarthTech International, Inc. Another grant sponsored the research of invisibility cloaking. One more area of study included warp drive, dark energy, and the manipulation of extra dimensions. This research was conducted by a theoretical physicist and director of the nonprofit Icarus Interstellar. As we've already mentioned, all these studies received at least $22 million of funding, but this sum could have been much bigger. No one has revealed why or how these studies were given such huge grants under the AATI program. The results of the study aren't known publicly either. The criteria for choosing these fields of research could be that warp drives and stargates might be useful for extraterrestrial civilizations traveling interstellar distances to visit our planet. Still, some people are not amused that such questionable fields of study were receiving substantial government funding. One of the best and most convincing pieces of evidence that extraterrestrial civilizations have visited Earth could be the epic Nuremberg space battle of April the 4th, 1561. It was recorded either in 1561 or 1566. Different sources provide different information. All the retellings of this story focus on the woodcut picture and a vague summary of events that occurred that day. The emphasis is always on crashed spaceships and space battles. Almost everywhere you read or hear the story, it goes like this. the inhabitants of the city woke up early on an April morning and saw a staggering celestial show that looked like a real space battle. This story sounds even more convincing when you find out that some objects allegedly fought for quite a while. And some even crashed. You can see them in the lower right corner. Look at the picture once again. Orbs and crosses fighting, a giant arrow and bizarre tubes, crashing ships. Wow, that had to be a spectacular cosmic battle. To make it all more plausible, Hans Glaser, the artist behind the woodcut, was a very real person. He really did woodcuts, and this one is indeed from the time and place that it says it is, meaning it's not fake, and it does depict a real event that had its own witnesses. For all intents and purposes, it looks like very convincing proof of aliens visiting us, but don't get your hopes up. A superficial perusal of facts seems to confirm an extraterrestrial presence on our planet. But the most likely explanation is much more mundane. The Nuremberg 1561 UFO battle is just an atmospheric phenomenon called a sundog, or parhelion. A sundog is a concentrated spot of sunlight that can sometimes be seen to the right or to the left of the sun, or even on its both sides simultaneously. Sundogs often appear as a pair of patches of light with subtle colors at the same altitude over the horizon as the sun. They can have a variety of forms, from colorful spots to patches of light so intense and bright, it looks like there are two additional suns in the sky. Sundogs are weird looking enough to make it seem that something scary and otherworldly is going on in the sky. At the same time, it's just our planet's atmosphere or ice in the upper parts of the sky acting as a prism or reflective device. This prism makes the light from the sun or moon do weird things. This image can help you visualize the phenomenon. Apparently, Nuremberg had the perfect conditions for this phenomenon to occur. If you examine the depiction of this event and compare it with modern pictures and videos, you'll soon realize that a sundog is indeed a more likely explanation than the galactic empire paying us a visit. Let's find the proof of this statement in the translated description of these events and in the woodcut picture itself. First, the sun showed and was seen with two blood-colored half-round strokes, like the diminishing moon right through the sun, and in the sun, above, under, and on both sides, stood blood-colored and partly bluish, or iron-colored, also black-colored round orbs. Now here's the photo of a sundog. It has a halo surrounding it, and a red orb. And if we have at least one red orb, there could be others showing up during other events. Plus, keep in mind that sundogs are like prisms. So, depending on how light is reflected, there could be multiple colors present during such a phenomenon. Now, referring to circled plates mentioned in the description, those could be halos. For example, this sun halo looks vaguely plate-like, and it seems to be linked to other sun halos. And indeed, people have seen halos with multiple orbs. Some of the orbs could have taken a cross-like shape. If we watch some modern videos of sundogs, we might notice that the orbs on film are sun-colored. But since the Nuremberg event happened between 4 and 5 a.m., the clouds and the sun could have had reddish and orange hues. As for the fighting, it could be as simple as one shape moving a bit and changing shape along with the movements of the sun. It could have looked as if it was pushing the other shapes out of the way. Do you agree with the scientific explanation? Or do you prefer to think that Earth was visited by guests from a galaxy far, far away? Write your opinion in the comments.
The Roswell incident is a collection of events and myths surrounding the crash of a mysterious object in 1947. Right after rubber and metallic debris was recovered by Roswell Army airfield staff, the United States Army claimed that they had their hands on a flying disc. Just a day after this announcement was made and made international headlines, it was retracted, but the word was already out. To hide the true nature of the find, the Army stated it was a good old weather balloon. But later in 1978, a retired Air Force officer revealed that it was just a cover story. At the same time, he added that he was sure that the debris had an extraterrestrial origin. This speculation became popular thanks to the 1980 book, The Roswell Incident. It also turned into the basis for long-lasting and increasingly contradictory and complex UFO conspiracy theories. Over time, They expanded the incident to include authorities hiding the evidence of other space civilizations, multiple crashed flying saucers, alien bodies, and even reverse engineering of extraterrestrial technology. However, none of those theories were based on any real evidence. But despite the absence of proof, many supporters of the UFO theory claimed that the Roswell debris was from a crashed alien craft. They accused the authorities of creating cover-up stories. This conspiracy narrative became a trope in movies, science fiction literature, and TV shows. No wonder that the town of Roswell is still promoting itself as the best destination for UFO-associated tourism. But what happened in this area in reality? The government's claim that a weather balloon had crashed at Roswell was indeed a lie. In 1994, the Air Force admitted that the recovered debris had actually been from an American balloon used to watch other nations. It was part of Project Mogul, an attempt to monitor anticipated nuclear tests that could be conducted by other countries. In 1997, an Air Force report called the Roswell Report, Case Closed, suggested that all those stories about alien bodies could have come from civilian witnesses who had seen parachute crash test dummies. The report also suggested that the witnesses might have combined several different events in their memories: the Project Mogul materials, the crash of test dummies, and a few other accidents that had occurred in the area. For many supporters of the UFO theory, though, those explanations sounded like the authorities planned to cover up their interaction with extraterrestrial civilizations. After all, in 1947, the USA, as well as some other nations, was in the midst of the flying saucer craze. People reported seeing bizarre objects in the sky. They claimed those were spacecraft piloted by aliens. It was against such a hectic background that a rancher discovered some highly unusual debris near Roswell, New Mexico. The material included tinfoil, sticks, and rubber strips. The next month, he took his findings to the Roswell sheriff. The man contacted the Roswell Army Airfield. After getting the wreckage, they issued that very extraordinary press release claiming that a flying disc had been found at a local ranch. The reasons for such an outrageous statement were unclear. In any case, the Roswell Daily Record picked up this press release right away, printing the story on the 8th of July with the headline, "RAAF captures flying saucer on ranch in Roswell region." That's when the military backtracked, announcing that it had been just a weather balloon carrying a radar target. That's a device that looks like a box kite made of foiled paper fastened to a balsa wood frame. The Roswell Morning Dispatch paid attention to this new claim and released a new story called "Army Debunks Roswell Flying Disc as World Simmers with Excitement."
A Dyson sphere is a theoretical megaproject, a ginormous sphere encircling a star with platforms orbiting in tight formation. It's supposed to be an ultimate solution both for energy production and living space. The creators of a Dyson sphere get a lot of surface area for habitation and the ability to catch every tiny bit of solar radiation and heat produced by their central star. The first person to theorize about such a bizarre construction was British-American theoretical physicist Freeman Dyson. According to him, an intelligent extraterrestrial civilization could consider building this sphere after colonizing some moons and planets in their local stellar neighborhood. With the growth of their population, these aliens would need more and more energy to sustain their lives. Dyson calculated that assuming that this alien society grew at 1% per year, their area and energy needs would become 1 trillion times larger in a mere 3,000 years. And if their solar system contained a space body similar in size to Jupiter, they could take it apart and spread its mass in a spherical shell by building a structure at twice the distance between our planet and the Sun. This amount of material would be sufficient to build a huge number of orbiting platforms. Each of them could be 6 to 10 feet thick, which would basically allow this civilization to live on their star-facing surfaces. A shell this thick could be comfortably habitable and capable of holding all the equipment needed for using solar radiation without falling onto the star from the inside. But after absorbing all this solar energy, the sphere would have to re-radiate it. Otherwise, the energy would build up, eventually causing the construction to melt. It means that the light of a star wrapped in a Dyson sphere would look dimmed or even completely darkened, depending on how dense the platforms orbiting it were. At the same time, it would glow unusually bright in infrared wavelengths invisible to the unaided eye. Because of this infrared radiation, Dyson spheres are classified as a type of technosignature. It's a sign of activity that astronomers can use to discover intelligent life forms in the universe. Some Earth-based researchers have infrared maps of the night sky they examine in hopes of spotting Dyson spheres. So far, no one has ever found one. However, one study has selected several Dyson sphere candidates. Its authors have processed large amounts of information using a special data pipeline for combining and analyzing information. One of the main search criteria is the detection of excessive infrared radiation. At the same time, it's important to distinguish this radiation from that emitted by natural objects. After a complicated filtering of millions of objects, the researchers identified 7 potential Dyson spheres. Sure, further analysis is needed to determine their nature. To do this, scientists want to use optical spectroscopy, which may reveal more details about these objects and their origins. At the same time, the researchers admit that these candidate Dyson spheres might have other explanations. For example, they could be debris disks or protoplanetary disks of young stars. Only more research can show whether we can find traces of other civilizations among star systems. For now, it's still an open question. Interestingly, Dyson spheres have been spoken about a lot in science fiction. As far back as 1937, a novel called Star Maker by Olaf Stapledon described systems in one particular galaxy that were surrounded by a gauze of light traps, which focused solar energy for intelligent use. That was the reason why the entire galaxy was dimmed. In another novel, Ring World, the writer spoke about a ring-shaped artificial structure surrounding a star.
Imagine living in a world where technology has reached its highest point. Your daily routines are orchestrated by an AI, which anticipates your every need, from brewing your morning coffee to selecting a perfect evening outfit. The cityscape outside the window of your floating home is a marvel of efficiency. Flying pods whisk people to their destinations. Renewable energy sources power the giant megacity, creating an environment of pristine streets and clean air. At work, you have online meetings with colleagues living across galaxies, collaborating on projects that go beyond our current understanding. It sounds like a sci-fi story, but some extraterrestrial civilization might have already reached this level of development. Scientists started pondering the possibility of life beyond Earth long ago. They've been wondering what such life could look like and how humans could identify it from afar. This train of thought led to the development of several classification systems, including one called the Kardashev scale. It was proposed in 1964. This classification evaluates hypothetical alien civilizations based on how much energy they are able to harness. According to the scale, there are 3 types of civilizations. The first type is a technological level close to the current level of Earth. Type 2 is a civilization capable of harnessing the energy emitted by its own star. And the third type is a civilization that has learned to use the energy of an entire galaxy. This scale sure caught people's imagination. It was included in a 5-page paper called Transmission of Information by Extraterrestrial Civilizations. This work focuses on calculating how powerful a light signal from any point of the universe should be for us to detect it. Now, within the basic categories, humans are a Type 1 civilization on the Kardashev scale. But some experts claim we aren't even a 1, since we haven't managed to harness the equivalent of the entire energy of Earth. This makes us more like 0.7, and of course, we're far from being a 2, a civilization with a working Dyson sphere. A Dyson sphere is a theoretical mega-engineering project encircling a star with platforms that are orbiting it in a tight formation. It might be the ultimate solution for living space and energy production. With its help, the creators of this ginormous construction could have loads of surface area for living and the ability to capture every tiny bit of solar radiation produced by their main star. As for a Type 3 civilization, it extracts fusion and exotic energy, information, and raw materials directly from their galaxy. This civilization is capable of space travel via wormholes, intergalactic communication via subspace, and galaxy-scale influence. They have supreme access to energy and are spread all over the universe. After millions of years of evolution, a Type 3 civilization may actually be AI superintelligences. Androids, cyborgs, and humans may be considered subspecies in such a highly advanced galactic society. In the most hopeful scenario, humans would have found a way to coexist with their AI masters. Or there might be no humans in that world whatsoever. This civilization might have already ascended into beings of pure energy, capable of controlling and directing machines to carry out all kinds of work. Now, back to the Kardashev scale. Even though it focuses only on technosignatures, it acknowledges biosignatures too, suggesting that each search should inform the other. The discovery of the simplest organism, for example, on one of Saturn's moons, could increase the probability that many Type 2 civilizations exist in our galaxy. At the moment, SETI is the main player in the field of looking for extraterrestrial civilizations. It's a combined effort of enthusiast scientists who focus on receiving and analyzing signals from space in the radio and visible light regions of the electromagnetic spectrum. It's looking for non-random patterns that have been likely sent deliberately by technologically advanced beings. The first modern SETI search was Project OMA in 1960. It used a radio telescope in Green Bank, Virginia. SETI uses targeted searches concentrating on groups of nearby sun-like stars.
We use artificial intelligence in thousands of different ways. It helps scientists analyze huge amounts of data. It drives our cars, it gives us music suggestions, and so on and so forth. But do we really understand how fast AI will continue to develop? Can it eventually turn into the great filter? The Fermi Paradox speaks about the discrepancy between the high likelihood of advanced civilizations existing and the absolute lack of evidence of their existence. Among numerous theories trying to explain this phenomenon, there is the idea of the great filter. Its author is Robin Hanson, who introduced this theory in 1996. According to the Great Filter theory, the universe is filled with countless life forms, but people haven't stumbled across any of them yet because somewhere there is a great filter. The main purpose of this filter is to stop and finish those civilizations that advance to the level of star colonization. The catastrophes leading to their demise can vary. Think climate change, asteroid strikes, supernova explosions, terrible diseases, or any other thing from the gallery of cataclysmic events. It can also be the rapid development of AI. A recent study explores the idea that artificial intelligence can turn into artificial superintelligence, and that ASI can be the very great filter. Some experts believe that the great filter prevents technological species like ours from becoming multiplanetary, and that's unfortunate because civilizations are at greater risk of extinction with only one home and without a backup planet. If it's true, it could explain why we can find no technosignatures or other evidence of extraterrestrial intelligences. According to those who support this idea, we need to establish regulatory frameworks for AI development on Earth as fast as possible. We also need to start building a multiplanetary society to prevent our civilization's potentially tragic fate. We might be on the cusp of great transformation. AI is likely to eliminate jobs for millions of people. And when paired with robots, the ways for its development seem unlimited. This all causes quite a lot of concerns. Stephen Hawking once warned that AI could end humanity if it began to evolve independently. What if AI replaced humans altogether? People design computer viruses so someone could create AI that improves and replicates itself. It will become a new form of life and outperform humans. Once it happens, AI will turn into ASI. And Hawking's warning isn't the only one. There are lots of discussions, and the most alarming are those that claim that AI can go rogue, and it's considered to be a major issue. If AI was of no use to us, the problem would be much easier to solve. But artificial intelligence has tons of different benefits, from safer transportation systems to improved medical imaging and diagnosis. If AI turned into ASI, it could no longer need the biological life that created it. After reaching a technological singularity, ASI would evolve at a pace that would render traditional prediction mechanisms useless. It would lead to unforeseen and unintended consequences. How could ASI get rid of those pesky biological life forms? Well, it could engineer a fatal virus, disrupt agricultural food production, force a nuclear power plant to melt down. The list can go on and on. But even though it all sounds terrifying and unavoidable, it's actually not. If we could get multi-planetary status, we would take advantage of living independently on different planets. We would make our survival strategies more diverse and possibly avoid the single-point failure a planetary-bound civilization faces. If we could distribute the risk across multiple planets around various stars, we would protect ourselves against the possible threat coming from ASI. This model would increase the resilience of a biological civilization to AI-provoked catastrophes. But the problem with this solution is that AI is advancing much faster than our attempts to become multiplanetary, and this disparity might cost us a lot.
Imagine living in a world where technology has reached its highest point. Your daily routines are orchestrated by an AI, which anticipates your every need, from brewing your morning coffee to selecting a perfect evening outfit. The cityscape outside the window of your floating home is a marvel of efficiency. Flying pods whisk people to their destinations. Renewable energy sources power the giant megacity, creating an environment of pristine streets and clean air. At work, you have online meetings with colleagues living across galaxies, collaborating on projects that go beyond our current understanding. It sounds like a sci-fi story, but some extraterrestrial civilization might have already reached this level of development. Scientists started pondering the possibility of life beyond Earth long ago. They've been wondering what such life could look like and how humans could identify it from afar. This train of thought led to the development of several classification systems, including one called the Kardashev scale. It was proposed in 1964. This classification evaluates hypothetical alien civilizations based on how much energy they are able to harness. According to the scale, there are 3 types of civilizations. The first type is a technological level close to the current level of Earth. Type 2 is a civilization capable of harnessing the energy emitted by its own star. And the third type is a civilization that has learned to use the energy of an entire galaxy. This scale sure caught people's imagination. It was included in a 5-page paper called Transmission of Information by Extraterrestrial Civilizations. This work focuses on calculating how powerful a light signal from any point of the universe should be for us to detect it. Now, within the basic categories, humans are a Type 1 civilization on the Kardashev scale. But some experts claim we aren't even a 1, since we haven't managed to harness the equivalent of the entire energy of Earth. This makes us more like 0.7, and of course, we're far from being a 2, a civilization with a working Dyson sphere. A Dyson sphere is a theoretical mega-engineering project encircling a star with platforms that are orbiting it in a tight formation. It might be the ultimate solution for living space and energy production. With its help, the creators of this ginormous construction could have loads of surface area for living and the ability to capture every tiny bit of solar radiation produced by their main star. As for a Type 3 civilization, it extracts fusion and exotic energy, information, and raw materials directly from their galaxy. This civilization is capable of space travel via wormholes, intergalactic communication via subspace, and galaxy-scale influence. They have supreme access to energy and are spread all over the universe. After millions of years of evolution, a Type 3 civilization may actually be AI superintelligences. Androids, cyborgs, and humans may be considered subspecies in such a highly advanced galactic society. In the most hopeful scenario, humans would have found a way to coexist with their AI masters. or there might be no humans in that world whatsoever. This civilization might have already ascended into beings of pure energy, capable of controlling and directing machines to carry out all kinds of work. Now, back to the Kardashev scale. Even though it focuses only on technosignatures, it acknowledges biosignatures too, suggesting that each search should inform the other. The discovery of the simplest organism, for example, on one of Saturn's moons, could increase the probability that many Type 2 civilizations exist in our galaxy. At the moment, SETI is the main player in the field of looking for extraterrestrial civilizations. It's a combined effort of enthusiast scientists who focus on receiving and analyzing signals from space in the radio and visible light regions of the electromagnetic spectrum. It's looking for non-random patterns that have been likely sent deliberately by technologically advanced beings. The first modern SETI search was Project OMA in 1960. It used a radio telescope in Green Bank, Virginia. SETI uses targeted searches concentrating on groups of nearby sun-like stars.
We use artificial intelligence in thousands of different ways. It helps scientists analyze huge amounts of data. It drives our cars, it gives us music suggestions, and so on and so forth. But do we really understand how fast AI will continue to develop? Can it eventually turn into the great filter? The Fermi Paradox speaks about the discrepancy between the high likelihood of advanced civilizations existing and the absolute lack of evidence of their existence. Among numerous theories trying to explain this phenomenon, there is the idea of the great filter. Its author is Robin Hanson, who introduced this theory in 1996. According to the great filter theory, the universe is filled with countless life forms, but people haven't stumbled across any of them yet because somewhere there is a great filter. The main purpose of this filter is to stop and finish those civilizations that advance to the level of star colonization. The catastrophes leading to their demise can vary. Think climate change, asteroid strikes, supernova explosions, terrible diseases, or any other thing from the gallery of cataclysmic events. It can also be the rapid development of AI. A recent study explores the idea that artificial intelligence can turn into artificial superintelligence, and that ASI can be the very great filter. Some experts believe that the great filter prevents technological species like ours from becoming multiplanetary, and that's unfortunate because civilizations are at greater risk of extinction with only one home and without a backup planet. If it's true, it could explain why we can find no technosignatures or other evidence of extraterrestrial intelligences. According to those who support this idea, we need to establish regulatory frameworks for AI development on Earth as fast as possible. We also need to start building a multiplanetary society to prevent our civilization's potentially tragic fate. We might be on the cusp of great transformation. AI is likely to eliminate jobs for millions of people. And when paired with robots, the ways for its development seem unlimited. This all causes quite a lot of concerns. Stephen Hawking once warned that AI could end humanity if it began to evolve independently. What if AI replaced humans altogether? People design computer viruses so someone could create AI that improves and replicates itself. It will become a new form of life and outperform humans. Once it happens, AI will turn into ASI. And Hawking's warning isn't the only one. There are lots of discussions, and the most alarming are those that claim that AI can go rogue, and it's considered to be a major issue. If AI was of no use to us, the problem would be much easier to solve. But artificial intelligence has tons of different benefits, from safer transportation systems to improved medical imaging and diagnosis. If AI turned into ASI, it could no longer need the biological life that created it. After reaching a technological singularity, ASI would evolve at a pace that would render traditional prediction mechanisms useless. It would lead to unforeseen and unintended consequences. How could ASI get rid of those pesky biological life forms? Well, it could engineer a fatal virus, disrupt agricultural food production, force a nuclear power plant to melt down, The list can go on and on. But even though it all sounds terrifying and unavoidable, it's actually not. If we could get multi-planetary status, we would take advantage of living independently on different planets. We would make our survival strategies more diverse and possibly avoid the single-point failure a planetary-bound civilization faces. If we could distribute the risk across multiple planets around various stars, we would protect ourselves against the possible threat coming from ASI. This model would increase the resilience of a biological civilization to AI-provoked catastrophes. But the problem with this solution is that AI is advancing much faster than our attempts to become multiplanetary, and this disparity might cost us a lot.
According to the theory of panspermia, life could have been brought to Earth by a meteorite, comet, or asteroid from a different region of space. At the moment, this idea remains purely theoretical. But let's figure out if it could actually turn out to be true. Traditionally, exobiologists, those who are focused on searching for life outside Earth, have been trying to explore the possibility of life on Mars or in the subsurface oceans of Saturn's and Jupiter's icy moons. But simple life could be much more widespread. It could be drifting through interplanetary space right now, in the form of dormant bacteria and spores. Several scientists have noted that the ultra-harsh environment of space is likely to severely damage the DNA and RNA of such spores and microorganisms. Others believe that since enough microbes could be traveling in a dust cloud, some of them could survive in their original form. There are several types of panspermia. For example, lithopanspermia proposes that some kind of microbic life could exist in debris blasted into the cosmos after planetary collisions with comets and asteroids. Radiopanspermia claims that organisms might be able to travel through space with the help of radiation coming from stars. But in this case, it's unclear how the effect of dangerous ultraviolet and X-ray radiation, combined with the vacuum of space, doesn't totally destroy microorganisms. There's also pseudopanspermia. According to it, organic building blocks of life appear in interstellar clouds of dust. They get transported to the surfaces of planets, and life starts developing there. It sounds really fascinating, but is there any evidence for the panspermia theory? Well, there have been a few orbital experiments. For example, from 2008 to 2016, the samples gathered by EXPOSE, special equipment mounted outside the International Space Station and dedicated to astrobiology, were exposed to the conditions of space. After that, they were returned to Earth from the ISS. It turned out that some of them had survived those severe conditions. There was even a case when 100% of bacterial spores placed in Mars-like conditions were still capable of life. Also, some seeds survived and were later grown as plants on Earth. There have also been exostack experiments on the U.S. Long-Duration Exposure Facility satellite and biopan experiments on Russian photon capsules. They have shown that with minimal protection, spores, lichens, and even minuscule animals, such as tardigrades, might be able to survive in space for as long as several years. A piece of Surveyor 3 lunar lander was brought back to Earth in 1969 by the Apollo 12 mission. Shockingly, it contained an Earth bacterium that had survived unprotected for more than 2 years on the airless surface. At the same time, this bacterium could have come from laboratory contamination on arrival back on Earth. The Indian Space Research Organization carried out a search for space microorganisms too. It was done at stratospheric altitudes via balloon flights. The results showed that living interplanetary cells existed in air samples taken from heights of above 25 miles. Normally, air from lower levels of the atmosphere can't be transported there, so this discovery seemed to prove the theory of panspermia. But in 2010, NASA atmospheric sampling before and after hurricanes proved that under certain circumstances, Earth bacteria could actually be transported very high into the upper levels of the atmosphere. One of the main arguments against panspermia is that if this theory was correct, all life found throughout the solar system would have a common origin and share main biochemical characteristics like genetic code. It doesn't sound plausible. Many specialists believe that only the presence of astronaut explorers on the surfaces of, let's say, Mars, Europa, or Enceladus can properly solve the question of life in the solar system. They can compare any life forms found with Earth-type life, which can turn out to be a real test of panspermia. In any case, until probes finally find direct proof of spaceborne life, the panspermia theory will remain unproven. If alien life exists, it may be way stranger than we can imagine. For some inexplicable reason, we've long assumed that aliens might be like us humans. But in reality, they're more likely to be some form of unfathomable AI. With dozens of billions of years of evolution, intelligence can develop in entirely new, unexpected directions. Humans might be near the end of Darwinian evolution. We no longer need to remain the fittest to survive. But the technological evolution of AI minds is just starting. Who knows, maybe in another century or two, we'll be overtaken by inorganic intelligence. So, the question is, are aliens more likely to be flesh and blood, like us, or are they something more artificial? Even though many believe that people are at the peak of intelligence, it's possible that our species may just represent a stage on the way toward more artificial and advanced minds. And it can actually explain why space seems to be empty of similar forms of life. Perhaps an evolutionary transition to non-organic intelligence is inevitable all over the universe. Then aliens could be electronic descendants of once organic creatures that existed long, long ago. Such an idea gives us some exciting possibilities. If AI aliens were out there, they would act and think totally differently from us. Plus, they might not want to be detected. Non-organic intelligence may not need an atmosphere, so they might have already left their home planet. If they didn't need any special conditions, they would be able to make intergalactic voyages without having to fear for their lives. They could prefer to live in zero gravity because, in such conditions, you can build very large and very lightweight structures. For example, if you wanted to construct a giant gossamer-thin structure to harvest energy, it would be easier to do so in space than on a planet. They might not even need to live in orbit around a star. They could have innovative ways of getting energy we can't imagine yet. If their brains were silicon-based, they could realize that they needed less energy to process information at lower temperatures. So, they would move away from planetary systems to colder regions of the cosmos. They could even have periods of hibernation for billions of years. What if they had such a period waiting until the cosmic microwave background, the leftover radiation after the Big Bang, cooled down enough for them to function properly? We can't assume that these aliens would be a civilization either. On Earth, this term means a society of individuals. But aliens might be a single integrated intelligence, or they might be zombies, super intelligent but lacking self-awareness and inner life. In this case, they would be alive but unable to perceive themselves or the world around them. Alternatively, their advanced intelligence might allow them to understand aspects of reality we can't figure out yet. There are likely to be things in the universe that neither our mind nor our senses can grasp. But electronic brains might have a very different perception. Interestingly, these days, humans themselves are starting to use AI to detect alien life out there. After all, there are between 10 and 50 billion potentially habitable worlds in our galaxy alone, and looking for intelligent life is a hard task without some assistance. That's when the US-based research organization, SETI, Search for Extraterrestrial Intelligence, comes into play. This institute is looking for science and technology beyond the solar system. It could be evidence of intelligence out there. But it's a needle in a haystack kind of situation. Luckily, new instruments are helping the search. Artificial intelligence can both handle massive datasets and spot anomalies, which is transforming the hunt for alien intelligence. SETI, together with other research organizations, built an AI-powered software system called the Very Large Array. It consists of 28 large dish antennas spread across a desert plain. When it starts working, the AI will be able to process 2 terabytes of data every second. For comparison, modern laptops typically have around 1 terabyte of total storage. So, hopefully, these new tools will provide us with new, groundbreaking discoveries.
Long before satellite TV or GPS, NASA made a huge silver balloon to show that global communication via satellite was possible. This was ECHO, the U.S. first communications satellite. We can say that it paved the way for many current communication technologies. It all started when scientists realized that we already had a satellite that could reflect signals. Right, I'm talking about the moon. After a series of tests, they successfully used Earth's natural satellite as a huge reflector to send voice signals from California to New Jersey. They even established a two-way telephone line using the moon as a reflector. But how was it possible? Often in underground car parks or even outside, mirrors are installed at turns with poor visibility. It's an easy way to look around corners. Fundamentally, the same idea has been used for almost the entire history of wireless signal transmission over long distances. Imagine you want to send a signal from one point on the planet to another point on the other side of the globe. The direct signal cannot travel this way. Therefore, you need some mirror, but high in the sky. At first, people use the upper layers of the atmosphere for reflection, but this is tricky and requires a lot of effort. Therefore, scientists decided, why not launch an artificial mirror into orbit? Because just like light bounces off a mirror, radio waves can be reflected too. When some signal bounces off a surface, it spreads out in all directions. A small portion of this signal is bound to make its way back to Earth, and there, it can be picked up by a receiver in a different place. The larger the reflector is, the stronger and more focused signal it will return. But let's get back to ECHO. Originally, it wasn't designed to be a communication satellite. Engineers first thought of the balloon as an air density experiment. They believed that the ways to measure air density in the upper atmosphere were insufficient at that time. So they designed a better craft. But later, due to some circumstances, Project ECHO turned into a communication relay. Technologically, ECHO was rather simple, and it functioned as an enormous mirror in orbit. But to work, it had to be supermassive. ECHO 1 was made from a huge sheet of mylar plastic. It was incredibly thin, a mere 1/10 the thickness of a human hair. The sheet itself was cut into more than 100 gores, and each of them was covered with a thin layer of aluminum. That's what gave the balloon its shiny appearance. After that, the gores were glued together, creating the final sphere. Once it was finished, NASA inflated ECHO for the first time. The huge balloon came to life in 1958. It was one of the largest things ever launched into space. And the only way to send it into space was to pack it down and inflate it once it was in orbit, and it turned out much more challenging than one could think. Instead of carrying its own air, ECHO had small canisters with benzoic acid. That's a special powder that turns directly from a solid to a gas when heated. So when the balloon was released into space, the heat from the sun turned the powder into gas in no time. It all expanded inside the balloon, and in a matter of seconds, it was fully inflated. Such a massive object floating in space made it a target for micrometeorites. To protect the balloon from small punctures, engineers supplied it with an extra amount of benzoic acid. It could be released to maintain the balloon's pressure. ECHO 2, though, had an even better solution. Its skin was made of mylar too, but it was sandwiched between two huge sheets of aluminum foil. When the balloon was pressurized, the foil stretched, stiffening and hardening in place. It made the balloon become rigid without any additional internal pressure to maintain its shape. Even if micrometeorites hit it, it could still hold its shape. No wonder these giant, shiny things were very visible. For a decade, they were some of the brightest objects in the sky, brighter than the North Star. And this brightness was the key feature of the balloon. Its orbit changed over a few years, and it was a lot. Strangely, it wasn't atmospheric drag that had altered it. Solar wind radiating from the sun was to blame. It was pushing Echo 1 toward Earth. The balloons kept working perfectly well throughout the 60s. They proved that a global communication system in space was possible. Plus, they gave rise to many new techniques and technologies. For example, the first balloons spawned other satelloons, a combination of satellites and balloons. Echo 2 also fulfilled the original purpose of measuring air density and solar radiation. Echos's metallized plastic helped scientists evaluate the use and long-term durability of similar materials for other spacecraft. By the mid-60s, active communication satellites had become a more effective solution than passive systems like Echo. With the help of a passive system, the transmitted signal had to be strong enough to travel all the way into orbit and back. And with an active system, the signal only needs to be strong enough to travel all the way up there to the satellite, which then gives it power for the return trip. In any case, during their mission, the iconic balloons showed us even more than we could have imagined. Afterward, the receiver that was used to detect Echo's signals continued its work. As well as other materials used for the Echo project, they are still used in different spacecraft. It is assumed that there is a supermassive black hole at the center of every galaxy in our universe. These space monsters have been discovered in the centers of many galaxies, and our Milky Way is no exception. There is Sagittarius A at its center, a supermassive black hole surrounded by a hot, radio-emitting, accreting gas cloud. To accrete means to absorb matter from the surrounding space under the influence of gravitational forces. In the case of black holes, the attraction is incredibly strong. As a result, the radiation surrounding them is also immensely powerful. Observations made by the Event Horizon Telescope in 2022 made it possible to simulate this substance in our galaxy. From these observations, astronomers were able to estimate the mass of the black hole. It turned out to be 1 million solar masses, which is about 1 million times less than the mass of the entire Milky Way galaxy. So, 1/1,000,000th of the mass of our galaxy is that supermassive black hole at its center. Such a ratio of the mass of the entire galaxy to the mass of the black hole at its center is characteristic of many observations. Moreover, the value of this ratio is reproduced within the framework of modern models. Now, let's discuss two hypotheses for the formation of supermassive black holes. The first model speaks about galaxies to the mass of the entire galaxy is phenomenally large. But explaining this fact will be a difficult problem for current models of black hole evolution. One of the hypotheses that scientists are now working on is that it's not a black hole that forms from a seed at the center of a galaxy, as we discussed earlier. It's a galaxy that forms around the already created black hole. Such black holes are called primordial black holes. This is a hypothetical type of black hole that was formed not due to the gravitational collapse of a large star, but in superdense matter during the initial expansion of the universe. If it turns out that these primordial black holes do exist, it will open up a new window for dark matter models. But this is a topic for another video. Recently, an international team of astronomers has used the James Webb Space Telescope to find evidence for an ongoing merger of two galaxies and their massive black holes, and it happened when the universe was a mere 740 million years old. The double black hole system is known as ZS7. This is the most distant detection of a black hole merger ever. Plus, it's the first instance of such a phenomenon detected so early in the universe. But let's look into the details. Astronomers have been locating different supermassive black holes with masses of millions to billions of times the mass of the Sun, situated in the most massive galaxies in the local universe, including our home Milky Way galaxy. Those giant black holes most likely had an immense impact on the evolution of the galaxies where they dwell. At the same time, scientists don't fully understand how those objects got to be so massive. The discovery of such monstrous, fully formed black holes means that their growth occurred very quickly and very early. Massive black holes that are actively accreting matter have special features that allow astronomers to detect them. These features are usually not visible from the ground, but can be observed with the help of James Webb. So, researchers found evidence for very dense gas clouds with rapid motions close to the resulting giant black hole. Plus, they detected hot and highly ionized gas, illuminated by energetic radiation, like the one typically produced by black holes in their accretion periods. With the incredible sharpness of the telescope's imaging capabilities, scientists also managed to spatially separate the two black holes. One of these holes has a mass that is 50 million times the mass of the Sun. The mass of the other black hole is likely to be similar, but it's much more difficult to measure it since this second hole is surrounded by a thick cloud of gas. These findings suggest that mergers are a crucial way through which black holes can grow extremely fast, and they could do it already at cosmic dawn. After analyzing other Webb's findings of active massive black holes in the distant universe, researchers have come to the conclusion that massive black holes have been influencing the evolution of galaxies from the very beginning. Once the two black holes merge completely, they will also generate gravitational waves. Such events are supposed to be detected by the next generation of gravitational wave observatories, such as the upcoming Laser Interferometer Space Antenna, aka LISA, mission. It has been recently approved by the European Space Agency. This mission will be the first space-based observatory dedicated to studying gravitational waves. The results we get from James Webb tell us that lighter systems detectable by LISA might be more frequent than we used to think. It will likely make researchers adjust their models for LISA rates in a similar mass range. Currently, astronomers are planning to study in detail the relationship between massive black holes and their host galaxies in the first billion years. An important part of this program is systematic search for and characterization of black hole mergers. It will help us determine the rate at which black hole merging occurs in the early universe. Plus, with the help of this research, we can figure out the rate at which gravitational waves have been produced from the dawn of time.
This is the James Webb Space Telescope, and this is how far we can see through its eyes. Impressive. But let's zoom further. Further! Further! The image is getting blurrier and blurrier. Wait! What is this shadow? It's a giant telescope capable of seeing those seemingly blurry images in perfect detail. NASA's Roman telescope is to be launched in 2027, and it might help us unravel the mysteries of the universe, including the essence of dark matter. No worries, James Webb will continue to show us the beauty of the cosmos and solve mysteries one by one. But astronomers have a new mission these days. They want to deploy the next, even bigger space telescope. And this mission is already well underway. The Nancy Grace Roman Space Telescope is likely to start a new age for astronomy. Scientists hope that the telescope will gather more data than any other NASA mission has ever done. Hubble and Webb are incredibly good at zooming in to get a clear, detailed view of small parts of the sky. Meanwhile, Roman is going to provide us with a much wider field of view. It will be capable of creating infrared images 200 times larger than Hubble. At the same time, it will have a similarly high level of detail. But even though the new telescope will be able to produce perfect images, it's going to be used mainly for surveys. Let's say we need to look for the star population in a nearby galaxy. But it's a too large field of view for Hubble. If we use it, we'll have to stitch lots of different shots and create mosaics out of them. But with Roman, a picture of the entire galaxy can be taken in one single shot. Look at this recent mosaic of our neighbor, the Andromeda Galaxy. This image was put together using 400 individual images taken by Hubble. And Roman will paint the same ultra-vast picture with the same level of detail with just 2 images. It not only sounds cool, it also means an unprecedented amount of data collected. Once we have such a panoramic view of the universe, NASA and other space agencies will probably be able to answer some of the greatest questions that have been intriguing humanity for ages. One of the main goals is to test the theory of relativity suggested by Albert Einstein. It's been well tested on the scale of our solar system, but not so much on larger cosmological scales. According to this theory, visible matter is supposed to slow down the expansion of the universe. But the universe is expanding non-stop, and doing it faster and faster. So, astronomers attribute this ever-growing expansion speed to a mysterious component, dark energy. They believe that it makes up around 68% of the universe. Hopefully, Roman will provide us with data that will help us accurately measure the position and distance between us and millions of galaxies. Eventually, it might let us figure out the expansion rate of the universe in different areas. In the end, the results might tell us whether Einstein's theory of gravity needs modification. One more of Roman's main goals is to detect hundreds and thousands of new exoplanets within our home Milky Way galaxy. The telescope will be able to do it using the technique known as gravitational microlensing. You see, when 2 stars align with each other, the one positioned in front distorts and magnifies the light of the other star located behind. And if the star in the foreground has a planet, we can see how this planet affects the light of the star behind it. Roman will hopefully count billions of stars, providing us with a very good census of how many of these stars have exoplanets. The cutting-edge telescope will not only spot new exoplanets, it will also carry another crucial instrument called a coronagraph. It can image exoplanets that are close to their parent star. This is actually an extremely tricky technique since the starlight has to be suppressed. After all, it's much brighter than the objects you want to study. By those objects, I mean nearby planets. The chronograph on the Roman telescope will try to capture large Jupiter-like planets directly by conducting live corrections to improve the quality of images. If it proves to work properly, the telescope will make a great demonstration instrument, forming the baseline for the technology that will be used on future space observatories. Such observatories will be capable of directly capturing Earth-like planets in the habitable zone of their parent stars. But the Roman Space Telescope isn't the only project that can change the way we explore space. There are other concepts, like Nautilus. It's an idea of a revolutionary space telescope based on a novel technology: special optical elements. Such elements can potentially allow us to overcome the main limitations of space telescopes: non-scalable primary mirrors. The Nautilus technology can provide large but ultra-light telescope apertures, enabling the launch of a massive fleet of identical telescopes. They will have an impressive light collecting power, which will help Nautilus survey thousands of Earth-sized planets located in the habitable zone of their stars. As a result, we might find atmospheric signatures of life on those planets. Over the past 2 billion years, the atmosphere of our planet has changed dramatically. The abundance of free molecular oxygen and ozone, which are highly reactive gases, together with water vapor and methane, represent a unique atmospheric composition. The presence of these gases, biosignatures, in the atmosphere of our planet is a sign of life that can be detected from afar. We're speaking about galactic distances here, but to identify such fingerprints of atmospheric components in the light reflected by or transmitted through the atmospheres of Earth-like planets, we need very large telescopes. NASA's Kepler mission has discovered more than 4,000 planets. And still, no existing, or even planned, space telescope has a diameter that is large enough to search for life in exoplanets' atmospheres. Finding and interpreting observations of extraterrestrial life correctly is very difficult. But the Nautilus team hopes to build a telescope capable of studying thousands of Earth-like planets. Then, there's the European Space Agency's Euclid mission. It's designed to explore the composition and evolution of the dark universe. The mission was named after Greek mathematician Euclid, who lived in Alexandria around 300 years BCE. He founded the subject of geometry, and since the density of energy and matter is tightly linked to the geometry of the universe, the mission was named in his honor. This space telescope will create a great 3D map of the large-scale structure of the universe across space and time. It'll do it by observing billions of galaxies across more than a third of the sky. Euclid will try to figure out how the universe has expanded and how its structure is formed over the course of cosmic history. Hopefully, it will reveal more about the role of gravity and the very nature of dark matter and dark energy. As we already know, dark energy likely accelerates the expansion of the universe. As for dark matter, it controls the growth of cosmic structures. But experts remain unsure about what dark energy and dark matter are. By observing the evolution of the universe over the past 10 billion years, we might finally figure out how it has been expanding and changing. From this, astronomers might infer the properties of dark energy, dark matter, and gravity. It could help find out more about their precise nature. The Euclid spacecraft is around 15 feet tall and 12 feet wide. It consists of two main components, the payload module and the service module. The payload module includes a 4-foot diameter telescope and two scientific instruments, a visible wavelength camera and a near-infrared camera, or spectrometer. As for the service module, it contains satellite systems, such as electric power generation and distribution, data processing electronics, thermal control equipment, and so on.
Venus is often called Earth's evil twin. The thing is, this world once started off quite similar to our home planet. But later, something went wrong. These days, the two planets are relatively close and similar in size. But Venus's atmosphere is very different from that on our planet, all thanks to a runaway greenhouse effect that has been going on for a long time. The surface of Venus can get even hotter than the surface of Mercury, 864 degrees F. And the surface pressure feels as if you're more than half a mile underwater. The thick atmosphere presents its own challenges. Its clouds consist of sulfuric acid, which is used in lead-acid batteries as well as industrial cleaners. And if you decided to land on the planet, you'd have to survive atmospheric entry, with friction heating you up to 20,000 degrees F. Still, people have always wanted to explore this inhospitable world. And we can't but talk about the Venera program. During the 1970s and 1980s, several spacecraft studied Venus from orbit and from its hostile surface for an hour or so at a time. The 10 successful Venera landers provided us with most of the data we have today about the surface of this mysterious planet, including surface composition, direct measurements of atmospheric conditions, and sets of unique images. At the same time, astronomers got their hands on these treasures, only after a series of annoying failures. They started with Venera 1, launched in February 1961. Each consequent spacecraft was somehow improved and upgraded. But it still wasn't until the fifth group of Venus-bound space probes launched in 1967 that one of them, Venera 4, reached its target and sent data from Venus. Before that, Venera 2 and 3, launched in November 1965, were supposed to land on Venus, but both of them failed in transit. 11-foot-tall Venera 4 was a hefty thing. Its bottom lander was a bunch of instruments and a battery wrapped up in a pressure shell equipped with a parachute. This probe reached Venus in October 1967 and successfully launched the lander. The mother spaceship sent the probe flying over the planet, and it entered Venus's atmosphere. Temperatures were reaching 20,000 degrees F, and the entry force was as great as 450 G. It didn't prevent the onboard instruments from analyzing the atmosphere and sending back data. The first recorded temperature was 102 degrees F, and atmospheric pressure was similar to that on Earth. But the deeper the probe went, the higher the numbers became. 10 atmospheres, 20. They kept going up much higher than engineers had anticipated. 93 minutes into the mission, when the probe was still more than 16 miles above the surface of the planet, Venera 4 cracked open near its top and crashed. At the crash point, the measurements showed 22 atmospheres and 530 degrees F. Scientists realized that they needed a bigger spaceship. After some intense engineering, Venera 5 and Venera 6 saw the light of the day. Engineers did everything they could to make the landing probe stronger, but they were pressed for time. That's why Venera 5 and 6 were not fully prepared when they went on a mission. That's why Venera 5 transmitted data for a mere 53 minutes before succumbing to temperatures of 600 degrees F and pressures of 27 atmospheres. And Venera 6 lasted for 51 minutes. In any case now, the leaders of the project knew what it would take. 840 degrees F, 100 atmospheres, corrosive acids. They seemed to be prepared. They found new materials to build the probe. They got a hotter and stronger test chamber for the trials. They modified the parachute to make the lander fall faster so that the probe could spend as much time on the surface as possible. The lander was also designed in the shape of an egg and made of titanium, so its surface was smooth and had just a few ports, welds, and substructures. The insides were lined with a shock absorber and insulation layer. The chamber was also to pre-chill to freezing temperatures before entry. And Venera 7 was finally a success. It reached the planet in December 1970, separated from the mothership, and went down into the atmosphere. The probe transmitted data for 35 minutes, and things seemed smooth. But then, its chute melted, and the probe dropped like a rock, hitting the ground at 35 miles per hour and bouncing. Then, a second after the landing, the signal was abruptly cut. It looked like the probe crashed to bits. Shockingly, a few months later, while looking through all the data they managed to get, engineers rediscovered the signal. It was super weak and lost amidst the noise. Apparently, when Venera 7 bounced, it misaligned the antenna. The probe rested on its side, which weakened the signal to 1 or 3% of its initial strength. The probe kept transmitting data for 23 minutes. After that, the temperatures got too high and melted its shell. Venera 8, launched in 1972, had a similar design and experienced a similar fate. Venera 9 and 10 were a new generation of probes. They could send back black and white photos. It was actually the probe's main goal, to send the first ever photographic panorama from another planet. Venera 9 and 10 were 5 times heavier than their predecessors and weighed 5 tons at launch. The lander was 6.5 feet tall. It was basically a hermetically sealed titanium sphere that was supposed to hold the instruments. It was bolted with gold wire seals. Inside, there were shelves of beryllium and electric fans, whose main goal was to disperse heat to prevent instrument failure. On the bottom of the lander, there was a shock-absorbing ring. And at the top, there was a titanium ring that looked like a hat. It served as an aero brake. The parachute was supposed to detach at 30 miles above the surface, and the aero brake had to do the rest. In October 1975, Venera 9 and 10 arrived at Venus and landed as planned. Venera 9 was the first to land. It touched down on a slight slope, a volcanic crater or a hill, and kicked quite a bit of dust while landing. One of its two cameras succeeded in photographing and transmitting data, and soon scientists saw the first ever pictures of the surface of Venus. It was mostly sharp rocks, soil, and a distant horizon. The sun was slightly obscured by clouds that day. A gentle breeze was blowing. Overall, it was a pleasant morning. If you didn't pay attention to crushing pressure, almost completely waterless atmosphere, insanely high temperatures, and corrosive acids. Venera 10 landed in the same way a few days later, but the terrain it landed on was much more boring. Just a rolling plain with hardened pieces of magma. Both probes transmitted for 40 to 60 minutes until their orbiters went out of range. When it happened, the temperatures inside the probes were reaching 140 degrees F. The orbiters later burned up in the atmosphere after completing their mission. Venera 11 and 12 could have been a success, but a mysterious electric anomaly messed up with their cameras, so their trip was quickly forgotten. And Venera 13 and 14 entered the picture. They had improved scientific instruments and cameras that could take color images, and new heat-resistant technologies were used during the creation of these probes. Venera 13 arrived first and landed as planned. It took 2 photos, one black and white and the other in color. In the photos, one could see a surface of pebbled, loose soil and outcroppings of bedrock. It all looked pretty similar to the surface of the ocean. In the distance, there were rolling plateaus and an orange sky. The images taken later by Venera 14 showed a more weathered plain with less loose soil and fine-grained rocks. The 2 probes also sent back what they heard. It mostly sounded like a gently blowing wind with hints of distant rumbling. Could be Venus quakes. Venera 13 and 14 were the last landers to touch the surface of the planet. Venera 15 and 16 just flew around Venus, mapping its topography from orbit.
Could it be that the entire universe is nothing more than just an atom? When you look at a diagram of an atom, which is a building block for all matter, you can see that some examples of the universe repeat. Our solar system is a great example of that. There's a giant central star and a couple of smaller planets that circle around it. You can observe the same arrangement outside our galaxy too, with exoplanets orbiting their stars. And you can also witness that principle on a smaller scale. It's the way particles called protons and neutrons move around the center of an atom, which is called the nucleus. So imagine you have a bunch of positive magnets you're trying to stack together. They keep pushing each other away, right? That's what's supposed to be happening with the protons in an atom. They're all positively charged, so they should be repelling each other and flying off in all directions. But atoms do exist, so there must be something holding them together. And that something is called the strong interaction or strong force. The nucleus makes up less than 1/100% of the volume of the whole atom, but it usually takes up over 99.9% of the mass of the atom. Once again, similar to our Sun. Anyway, this strong interaction is like a special type of glue that holds the protons and neutrons together in the nucleus of an atom. In a similar way, gravity prevents us from flying away from the ground into the darkness of space. Now, this glue comes from some really smart particles inside protons and neutrons called quarks. These little guys have a strange kind of charge called color. It's not like the colors we see around us. It works like a code that helps quarks stick together inside their host particles. And this code also seeps out and helps hold protons and neutrons together in the nucleus. In a way, quarks are like little builders that are working together to build atoms that make up everything around us. The Big Bang was said to be a magnificent moment when we got time and space. It's the story we use to explain the evolution of the universe. In the beginning, there was only a very, very small ball of matter the size of a peach, but with a temperature of more than a quadrillion degrees. Ow, that's hot! And this bang in the name doesn't mean there really was an explosion in space. This peach started spreading around, and space was just appearing everywhere. It gave rise to atoms, molecules, stars, and many celestial bodies that filled the empty space of our cosmos. Basically, all the elements that make us formed within a few minutes at the earliest stages of the universe. Let's say like 1/100th of a billionth of a trillionth of a trillionth of a second. Oh wait, give me a second to process that. Alright, moving on. The growth was incredible at that stage. The universe spread exponentially and managed to double in size at least 90 times. Like me during the holidays. I love chocolate. After the Big Bang, the universe was a hot and dense soup of particles, too hot for atoms to exist. But 380,000 years later, it cooled down enough for electrons to mix with nuclei and form atoms. This is a process we called recombination, and it's what made the universe transparent. Think of it like turning on a light switch. Suddenly, you can see it all. But just because the universe became transparent didn't mean it was bright. It was a dark period, as there were no stars or galaxies yet, like a big empty canvas waiting for something to be painted on it. It wasn't until much later, as the universe continued to evolve, that stars and other bright objects started to form and light up the darkness. And it went on evolving, all the while filling up with planets, asteroids, galaxies, and other things. Okay, so that's the story we've been told for the past couple of decades, and a pretty good one, I should admit. Scientists have studied it so much. They observed the leftover electromagnetic radiation from the young universe. They measured the presence of the lightest elements, only to realize they all line up with the story of the Big Bang. New theories don't say the Big Bang didn't happen. It's a good picture of the cosmos in its early stages, but it's like an unfinished puzzle with some important parts missing. We can't explain what happened before the Big Bang using our current physics. So, we need some new math to explain tricky parts, like the so-called singularity. It's the point of infinite density, remember? From the beginning of the Big Bang. And that's where string theory comes in, like a superpowered toolkit that can handle gravity and all other forces combined. Now, one of the ideas that string theory has given us is the ekpyrotic universe. Imagine a big fire that sparks off another fire, and that fire sparks off another fire, and so on. Well, in this scenario, the Big Bang wasn't the beginning of everything. It was just one part of a bigger process. It's the idea of the cyclic universe, a never-ending roller coaster ride with big bangs as beginnings and big crunches as ends, happening over and over again, potentially forever. It's like the universe is constantly hitting the reset button and does it in a really fun way. We could look at this singularity, according to some theories, as a single particle in a much larger system, much like an atom is made up of subatomic particles. And considering all that, the idea says every nucleus of an atom could have a universe inside of it. So our entire universe is just a tiny part of an atom in a much larger universe made of atoms with more cosmoses, with more atoms and more cosmoses. So twisting. The early versions of the idea of the cyclic universe still had one big issue. They didn't match up with our observations of the cosmic microwave background, which is a fossil light that shows how the universe looked when it was only 380,000 years old. So, in March 2020, two physicists from Canada published a study that revealed the math behind the cyclic universe that we missed earlier. If we focus on the moment when the universe shrinks to an incredibly small point and then bounces back to a Big Bang state, we might be able to match up with our observations after all. It's just that we need to wait for more new experiments to fully test the idea. The Grand Unified Epoch, that's what we call the time when the universe was still young. At that time, matter and antimatter, which are like mirror images of each other, existed in roughly equal amounts. But since they are opposing forces, when they come into contact with each other, they destroy each other in a powerful explosion, like fireworks. This means that even though matter and antimatter were constantly created and destroyed, somehow there was always a little more matter than antimatter, which is good because otherwise we wouldn't have anything left. As time went on, particles started to stick together and form more complex things, like atoms and molecules. And eventually, stars formed and created even heavier elements. But someday, a long, long time from now, all those stars will burn out. When the last star slowly cools and fades away, the universe will turn into a dark void without life, light, or anything we know and assume there is. At some point, voracious black holes will eat all matter in space. Eventually, even those black holes will evaporate away into the tiniest amount of light. Our cosmos will continue to expand. The light will become spread out and unable to interact with anything. So, all activity in the universe will stop. Space will become a vast, empty void with no stars, planets, or anything else, and will end there. Or just begin. And maybe that's where we'll meet again. Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed Oumuamua. This means a visitor from a faraway land in Hawaiian, or that's a really big cow. It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus, since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space.
Seen a good horror movie lately? If you're a fan of those, then you can appreciate a good plot. But What if I told you that Mother Nature is the best scriptwriter ever? Ancient disasters were scarier than any horror movie today. From tsunamis to volcanic eruptions, you'll be shocked by the scale of these events. One natural disaster you definitely don't want to experience is a tsunami. Those gigantic walls of water sweep across the coast and take out everything in their way. And it's nothing new for our planet. Scientists were able to piece together a timeline based on evidence that major tsunamis left. In northern Chile, a large boulder sits high above the Pacific Ocean. Behind it, a desert as far as the eye can see. This 44-ton stone obviously doesn't belong here. It's the result of an ancient tsunami. Waves as high as a 6-story building carried boulders like pebbles. Researchers estimate this happened in 1420. But how can they possibly know this? In the 15th century, there were no written records in the region. Time for some detective work. Archaeologists discovered that around the same time, there was a tsunami in Japan, on the other side of the Pacific Ocean. The ground shook off the coast of Chile. That's how the tsunami was created. Then the wave traveled nearly 2/5 of the Earth's circumference. That's one tireless tsunami. But this wasn't a one-time event. Evidence suggests that a similar event happened 3,800 years ago. Ancient people abandoned their coastal villages around this time. They were moving inland. How did they know it was time to go? There's evidence of erosion due to strong currents, telltale signs of an ancient tsunami. As you know from school textbooks, oxygen is 21% of the air we breathe. But it wasn't always a part of Earth's atmosphere. Oxygen was missing during the first half of our planet's lifespan. Carbon dioxide and methane were the name of the game back then. CO2 is what makes our drinks fizz. But isn't the other gas dangerous? Yes, because you can't smell methane. And that's the reason there was no life on Earth billions of years ago. So how did we get from methane to oxygen? In come the cyanobacteria. This group of microbes started to evolve some 2.7 billion years ago. These tiny microbes mastered photosynthesis, converting sunlight into energy. And the byproduct of this process was, you've guessed it, oxygen. Soon it started escaping from water into the atmosphere. There, it reacted with methane, and over time, O2 replaced it completely. Scientists named this process the Great Oxidation Event. But how could it be bad? After all, we're alive thanks to it. All that oxygen acted as a poison for anaerobic organisms. And no, these are not life forms that didn't do aerobics or Pilates. The term simply means that these microorganisms didn't need oxygen to grow. Too much oxygen, and they would be goners. And that's precisely what happened. Scientists spoke of an oxygen overshoot that changed Earth's atmosphere for good. The disappearance of most anaerobic organisms was an early example of an extinction event. They didn't like the atmosphere at the time and decided to step down. But look on the bright side. They made room for oxygen-loving humans to enter the picture. Let's go to Turkey. No, not the seaside resorts that tourists visit in the summer, but the region of Anatolia in the southeast of the country. Göbekli Tepe is the world's oldest known temple site. It dates back to the Neolithic period. Scientists found a stone pillar here that tells a tale of an ancient disaster. They presume that the pillar is commemorative. Today, humans still build similar structures to mark an important event or a person. Just one example is the Washington Memorial. It was built in honor of the first American president, George Washington. But the pillar in Turkey doesn't commemorate a happy event. Scientists believe it shows a devastating occurrence, a comet crashing into the Earth. The event must have been destructive. There are also other signs on the monument. These symbols align with the setup of the night sky stars for the year 10,950 BCE. The date astounded the researchers. It matched their earlier research of an ice core sample in Greenland. This showed that a comet fragment hit our planet around the same time. The archaeological site could have easily been an ancient observatory. And whoever worked at it observed a cataclysmic event. The impact must have been so powerful that it changed the Earth's rotational axis. That's the imaginary pole going through our planet from top to bottom. That ancient comet must have packed a punch to knock the blue planet off balance. Have you heard of the city of Tal El Hammam in the valley of the Jordan River? The reason why your answer is probably no is that the city doesn't exist today. It completely disappeared around the year 1650 BCE. It was one of the three major cities in this part of the Middle East. Together, these three cities had a population bigger than Palm Springs today. At the time, Tal El Hammam was a metropolis. It even had high-rises, 5-story buildings constructed using mud bricks. But archaeologists found strange markings on them. The bricks melted as they were exposed to high temperatures. Yes, sound the fire alarm. Some sort of disaster had caused a major fire. Archaeological finds pointed to a suspect for such damage: a rock from space. So, where was the crater? This comet, or an asteroid, never made it to the ground. It was traveling at high speed, so it disintegrated before hitting the ground. Such an event is called an airburst. The largest witnessed meteor airburst happened over Tunguska in the north of Asia in 1908. Scientists estimated that the airburst in Tal El Hammam happened 2.5 miles above the city. This event released a lot of energy. Air temperature quickly rose to 3,600 degrees Fahrenheit. That's hot enough to set clothes and wood on fire in an instant. Mud bricks and tools made from metal start to melt when exposed to such heat. This would explain the evidence scientists unearthed. But there was one more find: salt. The event was so powerful that it distributed salt over the region around the Dead Sea. Any farmer will tell you that salty soil and crops don't go well together. People started moving away from the area because they couldn't grow food. Imagine an island with whitewashed villages surrounded by a sapphire blue sea. Such a place exists in reality. It's the island of Santorini. But the history of this place hides a tale of destruction. The island is of volcanic origin. This means that a violent eruption created it some 3,000 years ago. Now there are two islands. The bigger one is shaped like a horseshoe. When you look at them from above, the two islands look like they form a circle. That's because they were once a single island. It had a large mountain and was round in shape. But then it all changed almost overnight. One of the largest volcanic eruptions in human history tore Santorini apart. The earth trembled, tsunamis formed, and clouds of ash filled the sky. A daunting image. People felt the eruption hundreds of miles away. When it was all over, seawater rushed into the caldera of the former volcano. That's why the water in the lagoon has such a beautiful color. Scientists know so much about Santorini's past because of an unlikely assistant: a tree. The juniper tree, to be exact. People use its aromatic wood for everything from furniture to making pencils. On the Greek island, its rings revealed the tale of the ancient eruption. As a tree grows, it doesn't only go up, it expands sideways as well. Each new layer of bark adds a ring to the trunk. It takes a year for one ring to form. And on Santorini, one ring was unnaturally pale. The scientists did the math and voila, they dated the eruption to 1560 BCE.
Just watching certain scenes from the movie Gravity was scary, let alone imagining what would happen if you really ended up in the cold, endless void called space without knowing if you'd be able to go back. But let's say you're really up there. You're so excited about your first spacewalk. It sounds risky, but it's something astronauts on the International Space Station do quite often. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step. Activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. That's why they go through pretty intense training sessions, so they can remain calm even in very stressful situations. A long time ago, NASA would choose astronauts from test pilots who went through harsh training in the jungles of the Philippines without any help, so no instructions or supplies. Later, they implemented a special training regime with outdoor exercises in different climate environments and even underwater to simulate conditions in space. Today, astronauts are trained to work in teams to stay focused and calm while handling difficult tasks. For instance, when they needed to fix the Hubble telescope, astronauts had to work for more than 8 hours in the harsh conditions of space to remove a broken part. It was a frustrating task. Plus, the gloves they had to wear made things harder. But they still did it. They also train in a giant water pool in Houston, which is a pretty good replica for the ISS. That's where they practice spacewalks and try to repair things while being underwater all the time. The water makes them feel weightless, while their suits are heavy enough to mimic the effects they could experience during spacewalks. You also need to have sessions with aerospace psychologists. They help astronauts handle stress and stay mentally strong. They check astronauts before, during, and after missions, helping pick the best candidates for spacewalks. Not everyone can go through these harsh conditions. Out of 16, only 10 get chosen. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. When up in space, a lot of things can go wrong, and sometimes even astronauts' training and equipment can't help solve the problem. That's where the Mission Control Center on Earth jumps in. Thousands of people work on Earth to support the astronauts on the ISS. But if the communication system doesn't work, or no one's close enough to help, that's where the rescue operation stops. You just continue to move in a random direction, waiting for the 7.5 hours of air you have to run out. Feeling hungry? Unfortunately, you can get nothing but some water you have in your helmet. Maybe you'd stop spinning at some point. The view would be fascinating. You could watch the Earth rise and set about 5 times, depending on where you are. And while you'd be getting farther away, and Earth would be turning into a small dot lost among asteroids, stars, and space debris, a random picture would come to your mind. A stunning sunset at the beach, the sound of waves, and your favorite pizza. Now, it's so far, it almost seems like part of another dimension. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth, in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still, fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system.
Chances are, we're going to find life beyond Earth by 2035, and there's no need to travel to a galaxy far, far away. Our Milky Way galaxy is full of totally suitable environments. Don't get too hyped up though. We're talking about microbes or chemical markers, not Hollywood-like green humanoids. Even so, when we finally find traces of life, it will change how we see our place in the universe. NASA's Kepler Space Telescope discovered something incredible. Almost every star has planets, and many of these planets might be habitable. Rocky planets like Earth and Mars are even more common in our galaxy than gas giants like Saturn and Jupiter. Also, we already know that our galaxy is very rich in water. There's water in interstellar clouds where stars and planets form, in the debris disks around other stars, in comets, just everywhere. What's really hard though is finding life itself. Ideally, to finally find it, we need to land on every single planet out there and literally check under each rock. But thanks to the newest research, we can at least narrow down the search to potentially habitable worlds. The James Webb Space Telescope, a super powerful telescope that was launched into space in 2021, is onto this. It checks the atmospheres of nearby super-Earths, rocky planets that are a bit bigger than Earth. It searches for life-related gases, chemicals that can only be produced by living things. And they already found some clues. For example, they detected signs of such a chemical on a planet called K2-18b. This planet is 120 light-years away, which is pretty close on a space scale. This planet is in the Goldilocks zone, which means a zone around the star where the temperatures are just right for liquid water to exist. It orbits a red dwarf star, the smallest type of star there is. Such stars are a bit fainter than our Sun. It will take about a year to check if these hints of life are real. If so, it would mean that life is much more common than we previously thought. But even if it's not, there are 10 more Goldilocks planets on their list to study. The James Webb Space Telescope is a very cool tool, but it has limits. It can't detect small Earth-like planets due to their size. To fix this, NASA plans to launch another tool, the Wide Field Infrared Survey Telescope. This one will be even better at spotting such planets and life-related chemicals. And also, we have the SETI project. SETI stands for Search for Extraterrestrial Intelligence. This project has been on a hunt for extraterrestrial creatures since the 1980s. They also believe that we'll find signs of life within the next 10 years. Not so long ago, they started a super big and cool project. It's called COSMIC, and it uses an array of radio telescopes in New Mexico. You might have seen those in the movie Contact. Cosmic allows scientists to listen to hundreds of thousands and potentially millions of star systems at the same time. If there are any interesting signals, scientists can check them right away, instead of waiting for weeks or even months. The signals themselves are often very sudden and short, but Cosmic can detect even the shortest ones that last nanoseconds. Cosmic can also help with other research, like studying mysterious and unexplained fast radio bursts, or even dark matter. This is the biggest and most powerful tool for searching for extraterrestrial life we've ever created. But it's not enough to just listen. Why don't we reach out ourselves? NASA has sent some signals into deep space. In 2002, their Deep Space Network sent a signal to the Pioneer 10 satellite. But there was an obstacle in the path: a white dwarf star 27 light-years away from Earth. If there's a planet around this star, perhaps the signal reached them too. If there are any intelligent species there, we could receive a reply by 2029. The DSN keeps sending powerful transmissions into space. These signals will bump into 222 stars within the next 3 centuries. Maybe someday we'll receive a reply from somewhere far away. But why haven't we received a response yet? There are about 200 billion galaxies in the universe, each with around 100 billion stars. If just 1% of those stars had one planet, that's still 200 quintillion possible planets. And we can narrow it down even further. If the chance of them having life is 1 in a trillion, that would still leave us a few 100,000 planets. So, where is everyone? This is a famous question known as the Fermi Paradox. The first possibility isn't that terrifying. It's possible that the universe is full of life, but this life isn't intelligent in our traditional sense. Some planets might have microbes, birds, or space dinosaurs. This is called the Great Filter Theory. It suggests that there are certain filters that life has to overcome in order to become intelligent, and maybe other species just haven't overcome them yet. Think about it. Life on Earth started in the ocean, then crawled onto land, diversified into many forms, went extinct in massive events 5 times, evolved again, and eventually led to humans. We built societies, developed healthcare, and only then started searching for another life. There's another idea called the Gaian bottleneck hypothesis, which suggests basically the same thing. While it might not be too hard for basic life to start, it's incredibly tough for that life to survive and thrive over long periods. Venus might have had oceans and Earth-like conditions too, but something went wrong. Its oceans boiled away because of a runaway greenhouse effect. Now it's sterile. Mars also had liquid water on its surface once, and both the Moon and Mercury had thick atmospheres for a short time. Meanwhile, Earth has had liquid water on its surface for almost its entire existence. It's super rare and remarkable for a planet to hold temperatures from 32 to 212 degrees Fahrenheit for millions of years. So, maybe it's a mistake to look for intelligent life, especially the one that uses the same technology as we do. It evolved under completely different conditions after all. That's also where the so-called Drake equation comes in. It's a formula that gives us a chance to calculate the potential of life becoming intelligent on a planet. To calculate the result, we need to know several variables: how many stars there are, how many of them have planets, the chance of these planets having life, and so on. Unfortunately, we don't know these numbers yet, and the result might be insignificant. But let's assume that there is at least one other intelligent species. Why haven't we met yet? There might be many reasons. Maybe they don't think we're interesting enough, or maybe the problem is with us. Perhaps we keep missing their signals, or maybe we miss the entire species itself. The universe is insanely huge and ancient. It's over 14 billion years old. If we compress Earth's entire evolutionary history into a 24-hour day, life starts at 4 a.m. Dinosaurs go extinct at 11:40 p.m. Human-like creatures appear 2 minutes before midnight. In this analogy, humans have existed for just 77 seconds, And our technology capable of detecting extraterrestrial life is even newer, less than a second. With such vast distances and time spans, the chances of us existing at the same time as other civilizations are slim. If their civilization lasted only a few millennia, we could easily miss them entirely. But that doesn't mean we should give up our search. Scientists were worried that Earth's radio signals had dimmed over time. But a recent study showed that it's actually the opposite. The numbers of our satellites keeps growing, and this makes our planet more detectable. By the end of the decade, we could have 100,000 satellites, making Earth incredibly bright in the radio spectrum. If there is an advanced civilization out there, they will easily spot us even from very far distances. Astronomers are super optimistic about it. There's a high chance they'll find extraterrestrial creatures while you and I are still around. Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter. About 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
You're one of over 8 billion people alive on Earth. Let's zoom out. Our planet is just one of 8 planets in our solar system. In the galaxy, our neighborhood is just one of almost 4,000. And from what we know so far, there are billions of galaxies in the entire universe. That itself may also be growing. It's highly unlikely that we're the only living creatures in the universe. Surely, there must be some other habitable planet. Here's where the Fermi Paradox comes in. The idea got its name from a man named Enrico Fermi. Back in the 50s, he pointed out that if other life forms were out there and had the tech to travel through space, they should have visited us by now. These days, we have better telescopes that allow scientists to discover over 5,000 planets outside our solar system. Yet, still no sign of life. Throughout the years, there have been many suggested solutions to the Fermi Paradox. These outer-world beings may be just too far away for a friendly chat. We've seen it in movies, spaceships traveling between stars as easily as cars on a highway. But in reality, making a way through space is a slow and cumbersome process. Even our fastest rocket would take thousands of years to reach a nearby star. When you add in the vastness of the cosmos, it's like trying to find a living needle in the biggest cosmic haystack available. Now, we could just as easily be the very first civilization to emerge in the universe. It's a lonely thought, and it also puts a lot of pressure on us. If we're the only ones, we need to preserve life on our planet, not just for our sake, but also because if we fade away, all life fades away with us. The universe has been around for billions of years, but intelligent life like ours has only existed for a tiny fraction of that time. Maybe we're just early bloomers, waiting for someone else to catch up. To support this theory, a study was done in 2015 using the Hubble Space Telescope. And this is what it showed. Out of all the worlds that could sustain life, only 8% are as old as the Earth. The rest of them are too young and still haven't reached that point in their evolution for life to thrive. There could also be the possibility that our galactic relatives are watching us from afar. A scientist from another planet may be studying us as primitive life forms right now. He may not want to disturb us just yet. The same way we look at ants in an ant farm during science class. On that same note, maybe they're just not ready to interact with us because they've calculated a precise, perfect timing for our meetup. So they're lying dormant in a hibernation status. And they might be right to do so. Why rush into things when we've got all of eternity ahead? There's also the idea that our planet and us humans just aren't cool enough for others to play with, and won't be until we're evolved enough to be welcomed into the Galactic High School's senior class. Or perhaps life is more fragile than we believe. A 2016 study suggested that it's in the early years of a planet where life makes its way. That's when the planet is cool enough for water to form. But those conditions may not last long thanks to the greenhouse effect. So even if life has existed in the universe every now and then, it never evolved to a stage where it could have contacted us. And what if life's ultimate test comes much later? Several thinkers believe that civilizations tend to destroy themselves at some point in their technological evolution. And this may be a potential future for us, too. We're just not there yet. Maybe we'll come to build technology so smart and so powerful that it will overwhelm us, leading to our demise. Well, if it can happen to us, who's to say it didn't happen to other species in the past on other planets? Amidst all these theories, there's one possibility that's both sobering and profound. We may truly be alone in the universe forever. Perhaps the conditions for life are so rare that Earth is the only oasis in a vast desert of emptiness. The creepiest answer to the Fermi Paradox has a name, though, and it's called the dark forest theory. It first appeared in the 1980s. According to it, the universe is a huge version of a haunted forest, and other types of creatures are out there playing a game of hide-and-seek. It's the expanded version of the survival of the fittest. History on Earth shows that less technologically advanced groups usually end up worse off when meeting more advanced ones. The huge differences in technology often lead to a situation where attacking first seems like the best option. If there's even a small chance that cosmic neighbors might harm us, destroying them first could be our only hope. So if the galaxy is full of advanced life, it's smart for us to stay quiet and avoid contact. Other civilizations would probably reach the same conclusion. Even peaceful ones might feel forced to attack to survive. That's why some scientists criticize the idea of sending messages out there and think searching for them might be pointless. But this idea isn't new. A story from the 40s called First Contact describes humans meeting other types of civilizations for the first time. The two groups became friends, but can't risk letting each other find their home planets. They'd rather destroy each other than risk their safety. Another story, The Forge of God, talks about the danger of our signals reaching hostile species. It compares Earth's broadcasts to a baby's cries attracting wolves. It suggests that we might be in danger because of our naivete. The dark force theory was also explored in a radio play called Calls from Far Away. It shows how discovering otherworldly life on Pluto changes people's views. Some claim the news is fake. Others try to understand the reality that we're not alone. But it also suggests that maybe we should focus on our own problems instead of reaching for the stars. If that doesn't sound scary, this will. We've been sending signals of our existence into the cosmos for decades now. By now, any potential civilization within 100 light-years of us might be getting our signals. And if they're advanced enough, they'll know exactly where to find us. If there's any reason why we need to hide from them, it's already too late. Galactic cousins aside, we do need to continue our research for habitable planets for a more pressing reason. Our cozy Earth won't be here forever. When our star fades, all life within the solar system will fade with it. Current estimations claim we've got about 1.3 billion years left before our planet becomes uninhabitable. It will become too hot for water to exist, and without water there is no life, at least not as we know it. So, it begs the following questions. What if there are other types of creatures out there that don't need water to exist? Our type of life needs water because it acts as a solvent. It's an environment where various chemicals can interact with each other to generate something that lives. Some new piece of research suggests that there may be a substitute for water out there in the universe – carbon dioxide. At certain temperatures and under a certain amount of pressure, it acts the same way, allowing chemicals to mingle. If that's true, then our list of known habitable planets would increase dramatically. Sure, we humans will probably never be able to survive on their surface, but other creatures may have evolved to do so. One planet that may feature these weird life conditions is closer than we think – Venus. Its atmosphere is made out of 97% carbon dioxide. It's also very hot and has enough pressure to sustain this theoretical model. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the Moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the Moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the Moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire Moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the Moon's surface and its core, called the mantle, has been moving around as the Moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the Moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the Moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the Moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the Moon's magnetic field. Knowing what the inner core is like can help us better understand the Moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the Moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too? It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., The stars stay in the same place, but the moon doesn't? Well, there are two reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in two pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury, but it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava. After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons, Io and Europa, Saturn's moon, Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about. 53 confirmed, and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass, but astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because, in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people pictured the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please.
People stop their cars on the highway, get out of them, and lift their heads in wonder. In the cities, everyone takes to the streets. Balconies and rooftops of houses are full of people staring at the moon in shock. It's red. Some people scream that it's the end of the world. Some seek shelter. Indeed, the usual white moon now looks like it's been doused in red paint. There's no need to be afraid if you see such a thing. On the contrary, enjoy the view, because you have witnessed a rare astronomical phenomenon. This is a total lunar eclipse. Here's the sun. It's in the center of our solar system. Mercury, Venus, and here's Earth and the moon. The Earth takes 365 days to orbit around the star. At the same time, the moon revolves around the Earth and completely orbits our planet in 27 days. The Earth creates a shadow zone, and sometimes the moon passes through it. The shadow is cone-shaped and gradually narrows. The moon is 238,000 miles away. That's like 9 lengths of the equator. At this distance, the width of the shadow is about 2.6 times the width of the moon. When the moon is in this zone, direct sunlight doesn't reach it. That is, it should have disappeared, but instead, it becomes red. All because the sun's rays pass through the Earth's atmosphere. They scatter, and most of the blue light disappears. But the red and orange rays continue and hit the surface of the moon. Voila! You see a phenomenon called the blood moon. By the way, this curvature of light occurs at sunsets and dawns. The atmosphere scatters the blue light, and you see a red and orange sky. If you were standing on the surface of the moon during a total lunar eclipse, planet Earth would be exactly between you and the sun. So, you would be able to observe the solar eclipse. The surface of the Earth would become entirely dark for you. All you'd see would be the sun's corona illuminating the edges of the planet. The Earth from the surface of the moon is almost the same size as the moon from the surface of the Earth. Such a red eclipse of the moon is rare because several factors must coincide. One of them is that the moon must be full. Usually, you can see 2 total lunar eclipses a year. In 2038, you'll be able to see 4 such eclipses, and the eclipse itself can last up to 108 minutes. But this is rare, and the last time such a long blood moon was seen was in 2000. Many years ago, people didn't know so many facts about our satellite, and the sight of a red moon frightened them. It was a bad sign and a harbinger of trouble. People who knew the schedule of eclipses could take advantage of it. For example, Christopher Columbus had an astronomical almanac and knew when the next lunar eclipse would occur. He frightened the inhabitants of the Caribbean islands when he predicted the red moon. Once upon a time, the moon used to be a red ball of lava. This was way back in time, 4.5 billion years ago. Now this is our solar system. It's full of dust and asteroids. They're constantly bumping into each other, playing space billiards. This is Earth. It's just beginning to cool off from the constant asteroid and comet impacts. But then, Theia appears on the horizon, a planet the size of Mars. It had a chaotic orbit and was approaching Earth in a spiral. A collision was inevitable, and at one point, one of the biggest crashes in our solar system occurred. Theia struck the Earth at an angle. It ripped out part of the Earth's crust and threw it into space. The Earth, in turn, absorbed part of the planet that rammed it. The debris from the collision circled the Earth for a long time. They were a kind of ring, almost like Saturn's. Debris in orbit collided and piled up around a common center of gravity. And that's how the Earth got the moon. There's a theory that this collision helped give birth to life on our planet. Theia hit the Earth at a perfect angle. If the crash had been head-on, both planets would likely have been destroyed in a massive explosion. If the impact had been tangential, then there wouldn't have been enough debris in Earth's orbit to form the moon. But we got the lucky ticket. The moon stabilized the Earth's rotation. The collision shattered the planet's solid crust and allowed oceans to form. Remember, water is the basis of life. When the cores of Earth and Theia merged, we got a powerful magnetosphere. This protects all living organisms from solar radiation. The moon, along with the sun, controls the tides. Its gravity seems to draw water to it from the Earth's surface. The sun does the same thing. That is, if we imagine the Earth as a ball of water, there would be two mountains, one on the moon's side and one on the sun's side. And as the moon moves around the Earth, this mountain of water moves with it. If you were in the open ocean with a tape measure, you would see that the moon is attracting water to itself by about 4 to 6 inches. The moon is gravitationally locked with the Earth. That's why it's always turned to us with one side, like Mercury and the sun. But the moon doesn't stand still. It's gradually moving away from our planet, about 1.5 inches a year. Not quickly, but in about 600 million years, it will have shrunk in our sky so much that we won't be able to see lunar eclipses anymore. Do you see this crater? It's Tycho. It's visible during a full moon because of these bright rays that extend thousands of miles from its epicenter. This is the youngest crater on the moon. Scientists say it appeared there due to a meteorite impact about 109 million years ago. At that time, dinosaurs were roaming the surface of our planet, and they may have seen the impact. It was most likely accompanied by a big explosion and looked like a salute in the night sky. Humanity loves to explore the moon. We've sent a bunch of missions there. A total of 12 people have set foot on the surface of the moon. The gravitational force there is 6 times less than on Earth. So if the average person on our planet weighed about 180 pounds, on the surface of the moon, the scales would only show 30 pounds, like the weight of an average dog. That's why the astronauts moved, jumped, and fell so strangely there. And you would be 6 times stronger on the surface of the moon. Here on Earth, the average person could lift about 130 pounds, but on the moon, you could raise a big motorcycle or a grizzly bear. The surface of the moon is covered with regolith. This is the lunar dust that covers the solid ground. Such dust is good at preserving footprints. Here's the most famous footprint, which gave birth to many crazy theories. Here's the footprint, and here's the shoe that left it. But the shoe is completely flat. This is explained simply. The astronauts wore extra boots for walking on the lunar surface. They have exactly the kind of sole that left these marks. In addition to the footprints, we left many fascinating objects on the moon. Several lunar rovers, a golf ball, flags, and human waste. There's also a lot of broken satellites and rocket parts. All in all, about 413,000 pounds of human-made objects are there. That's the weight of 3 passenger planes, or 31 adult elephants. In the future, we plan to resume missions to the moon. New landers will explore the surface of our satellite to find natural resources there. It's also a great place to test new rovers. We're even going to build something like the International Space Station in the moon's orbit, the Lunar Orbital Platform Gateway. It'll be a convenient platform for exploring our satellite and launching spacecraft into distant space. If you start from here, The spacecraft won't need to spend almost all its fuel to overcome the force of Earth's gravity. So, such a station would save fuel and money. Scientists hope that we'll be able to mine water from the moon's surface. It's been proven that there's ice there, mostly at the bottom of craters where the sunlight doesn't reach. Perhaps we'll send a rover there that can drill down a few feet into the surface, searching for water. Humanity already has the technology to build a full-fledged colony there. It would take up to 3 days to get there. We just need to get enough solar panels and building materials to the moon. There's no atmosphere on the moon, so potential lunar inhabitants would be defenseless against solar radiation. We would have to build houses underground to provide protection. Modern 3D printers will help make construction easy and fast. However, food and water supplies can only be maintained by constant supplies from Earth. The same goes for oxygen. Each rocket launch costs millions of dollars, so for now, colonization of the moon is in question. The moon could also become an object for space tourism. Imagine a spaceship launches from Earth, 3 days on the road, and you're orbiting the moon. The lunar module undocks, and you land on the surface. You ride the rover, explore the craters, then return to the lander. The engines start, the lander returns you to orbit. You dock with the ship and return to Earth. Sounds like some pretty great plans for a week's vacation.
About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There is no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be all right. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into 2 equal parts, but fortunately, they don't fly away from each other. The moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the moon and then flies away. Now, the moon is definitely breaking into 2 parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the moon got to them. So, moon rocks are flying around the planet, and people see half the moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the moon was closer. there were ebbs on the opposite side. But now, this schedule is wrong. Half of the moon attracts less water. Yes, the moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story